Hello everyone. In this video, we will talk about machine learning library using Spark. So first, let's do a quick review about machine learning techniques. So remember that we have multiple learning types, but the most popular are the supervised learning and the unsupervised learning. In the supervised learning, the idea is you have multiple observations. These are the rows in our databases, right? Let's say we have n observations, and there are multiple variables or columns up to xk. So you talk about supervised learning when there is one or more outputs. Typically, that's what we call the dependent variable. So it's the variable that you want to predict. So using these other columns, x1 up to xk, we want to find a model to be able to predict our y variable or our y variables if we have multiple variables. In the supervised learning, there are like two big problems. We can have regression problems or classification problems. So what is the difference between regression and classification problem? The main difference is in regression problems, our y variable, the output, the dependent variable, is numerical. While when we're talking about classification problems, the output or the target, it's a categorical variable. So for example, in regression, if you want to predict the price of a house, that's if we're talking about money, that's a numerical variable. So if you want to predict that value based on different features of the house, such as the area, the number of rooms, the location, so that would be a regression problem. Now, in the case of classification, if we're talking about transactions and you want to check whether the transaction it's a normal transaction or if it's fraud, then that will be a classification problem because the output it's a categorical variable. So this is supervised learning again because there is an output clearly identified and we want to use the other variables to be able to predict or find some like correlation between these variables. Now, on the other hand, you have unsupervised learning, and in the supervised learning, the difference is like you don't have the y variable. There is no dependent variable, no clear output initially. So we have observations from 1 to n, we have multiple columns, multiple x variables, but initially you don't have a specific variable that you want to predict. So the main idea of a supervised learning, and to be more specific, of clustering, because that's one of the problems here, like a common problem in unsupervised learning, is that you want to find some insights in your data. You want to identify some patterns in your data. Again, there are no output variables. There are only some columns. So the idea is to find like why some observations are equal to each other or what do they have in common. So you want to find groups or clusters when you perform a clustering analysis. It's a popular method when you're trying to explore your data, or sometimes you want to perform some customer segmentation to find different groups of customers to provide different service levels to the customers and create some like different policies or different strategies for each segment or for each cluster. Now in the supervised learning, you also have techniques for dimensionality reduction. So when you have like a lot of columns, sometimes you want to find which variables are redundant. So you perform some dimensionality reduction techniques to be able to reduce the dimensionality of your problem. Okay, so in the Spark, there is a machine learning library. So let me show you the documentation. Here. Now in this in the documentation, you can find like the common problems: classification, regression, clustering, collaborative filtering, which is used for recommender systems, model selection, and also the dimensionality reduction. So you will find like the common machine learning techniques. So now let's see an example on how it works using Colab. Okay, so in our previous lectures we covered how to install Spark and Hadoop. So I'm not gonna explain it again, but again you can just go to the previous video and see the explanation for this part on how to install Spark, Hadoop, how to set the environment variables, and we also show how to create a Spark session, which is this one. Now, what is new here is like here we're using the machine learning module of pyspark. So here we're bringing the vector assembler to change the structure of our data. The problem that I'm going to show you in this video, it's a regression problem, so that's why I'm using the linear regression model. This is just one of the algorithms that are available for regression, but there are more options. You can use like regression trees, random forests. There are multiple alternatives here. Same thing for classification problems. You will find multiple algorithms to be able to create multiple models. And the evaluation part is just to check the performance to see if the model is good or not. Okay, so let's talk about the problem that we have here. So first we load the data. It's in the file problem RLM1, which is available, you will find on Brightspace. This is just the first 5 observations in our data. So this is about a vending machine, and we want to predict the time it takes to replace the vending machine based on 2 variables: the number of bottles that are required to replenish, and the distance between the warehouse and the vending machine. So let's say that this time is in minutes, right? So this is our y variable, and bottles and distance, they are our x1 and x2. Okay, so first you can drop NAs if it's required sometimes. Then you identify which is the target, the output. In this case it's time, that's the name of the variable here. And the remaining variables, then there will be like the predictors. Okay, so here is where we start using the vector assembler, because the ML library here in PySpark requires the data in a different shape if you compare it with, you know, like other common libraries in Python, such as scikit-learn or similar libraries. Typically you have like multiple columns, but here what you do is that you have 2 columns. After you perform this transformation, you get data with only 2 columns. So let me show it to you. So once you apply that assembler to your data, so we get 2 columns. We get the label, that's our y variable, right? The time, the output. And then x1 and x2, they are combined in a single column. So we have like, you have vectors. Each observation here is like a vector with the 2 variables, right? Now if you have 4, 5, 10 variables, again, that will be like a vector with the 4, 5, 10 values per row. So this is like NoSQL, right? Like an embedded table inside this structure. That structures, we covered some of these structures in previous lessons. So this might be a little bit different to what you have seen in R and even in Python. But other than that, it's pretty much the same thing. Because once you have your data in these 2 columns, and this will be the same regardless you're doing regression or classification. So then you split your data, remember, cross-validation, the trained data, the test data. So here the split is 80% goes to the training data and the remaining 20% to the test data. Now we use the train the model, the linear regression model. This is where you fit the model. And then we print the coefficients, right? Beta 1, beta 2, and beta 0. So with this information, you can create your equation, right? The linear regression model will be like the y hat is going to be equal to beta 0, which is 1.2, plus beta 1, that will be 2.77 x1, plus 0.013 x2. That will be our linear regression model. Again, this is only one algorithm. You can also use regression trees here, random forest, KNN. There are multiple options. So once you have the model, you can see how it works in the new data with the test data. So this is how you see the predictions. So you're getting this is your y hat, right? So you have the x here, the variables, the original y variable, the original values, and then the predictions y hat. So you can compare, you can find residuals, compute different metrics, just to see like the distance between these two values. Remember, the idea is to minimize the error here. So finally, you can compute some metrics. Remember that we loaded the evaluator. So now we can evaluate the regression model using different metrics. So you can compute the root mean square error, RMSE, and also you can find the R square, which is popular when you're using the linear regression model. So here you get your numbers, right? In the case of the R square, it's high. Remember, it's between 0 and 1, so the closer it is to 1, it's good, unless you are doing some overfitting, but let's assume that here it's working in a good way. So as you notice, it's similar to what you have seen in the past. Maybe the main change is with the data structure here, when you use these vectors in a single column. But other than that, this is standard. It's common. It's like similar to other packages. Okay, I'm gonna stop the video here. In our final test, you will need to solve a regression problem using three algorithms, using the linear regression model, the random forest for regression, and also regression tree.